Welcome to the Builder Casing tab complete instructional video. In this video, we will cover casing strings, primary cement, tapered strings, liners, scaling and casing string parameters. The first step to drawing any wellbore diagram is to open the Wellbore Schematic Builder, which is located under the Wellbore Genie ribbon on the far left side of the ribbon. For this example, we'll load the same horizontal well profile with imported surveys that was used in the page and well path tutorial. Now we'll select the Casing tab to bring up all the casing features. Along the left side, you can select how many casing strings the well contains. For this demonstration, we will build a 4-string completion by checking the String 4 box, which will display all the casing options to the right. The casing must be ordered from largest to smallest. So for string 1, we'll add the surface casing. We'll click the OD drop-down arrow and select the casing size at 13 3/8 inches. In the box below that, we'll select the hole size at 17 1/2 inches. The next 2 boxes to the right, we'll enter the top and bottom depths. We'll set the surface casing from 0 to 800 feet. In the next section, we have the option to make it a tapered string, but we'll leave this to demonstrate for string number 4. Now we come to the cement section. Click in the drop-down menu. There are 3 options: none, lead only, or lead and tail. For this string, we'll select lead only. The next box is where we can specify the top depth of the cement. We'll leave it at 0, indicating cement goes all the way to surface. Finally, there are the shoe and liner hanger options, which you can check to display a shoe or a liner hanger. We'll leave the shoe box checked and the liner hanger box unchecked. Now we'll move on to string 2 and add the first intermediate casing. We'll follow the same process, adding the casing in hole sizes, 9 5/8 inch casing by 12 1/4 inch hole, top and bottom depths from 0 to 7,500 feet, and again we'll leave the tapered option unchecked. However, this time for cement, we'll select the lead and tail option. And in the bottom box, we'll specify a depth value to the bottom of the lead and the top of the tail interface of 5,500 feet. And we'll leave the shoe and liner hanger options again as they are. Moving down to string 3, we'll add the second intermediate string, starting with the casing and hole sizes, a 7-inch casing by 8 1/2 inch hole. But this string will make a liner, so instead of making the top depth be 0, we'll enter a top depth of 7,000 feet. Giving 500 feet a lap over the casing string 2, and set the bottom of the liner to 9,000 feet. Again, we'll leave the tapered option unchecked and select lead only cement with the top of cement at the top of the liner at 7,000 feet. We'll leave the shoe box checked, but since this is a liner, we'll go ahead and check that liner hanger box. The final production string, string 4, will again enter the casing and hole sizes. 4 1/2 inch casing by 6 1/8 inch hole, along with the top and bottom depths going from surface to TD at 26,310 feet. For this production string, we'll make it a tapered string by checking the tapered box. We now have to enter the swedge depth, which we'll put above the top of string 3 liner at 6,000 feet, along with the top casing OD, which we'll make 5 1/2 inches. One important thing to note for tapered strings: the lower smaller OD must be entered here, and the upper larger OD must be entered here. For the cement, we'll add only lead cement, but we'll make the top of the cement below the swedge at 6,500 feet, and then no cement from the taper to the surface. And lastly, we'll leave the shoe and liner hanger checkboxes as they are. Now we'll click Draw the Wellbore. With the wellbore drawn, let's go back to the top of the page where we can adjust the parameters to make the wellbore appear to our liking. First, let's adjust the scale factor up to 2.25 and hit refresh. Now the wellbore is larger, so we can see it more clearly. This option scales the diameter of the wellbore up and down as needed. Now let's adjust the bore factor and bring it down to 0.6 and hit refresh. So the center of the bore portion isn't quite so wide. This option only changes the inner bore size and will not change the thickness of any annulus. Moving to the right, we can increase or decrease the casing line thickness as needed. We'll decrease it to 0.75 and hit refresh to give it a sharper look. The shoe size is a bit large. We can shrink it down here. We'll adjust it down to size 3 and hit refresh. The hanger length is defaulted at 50 feet. However, since it appears as just a sliver on the diagram, we'll change it to 150 feet and hit refresh. Now we can see it much better. At the top left, the annular open hole trace feature displays the dotted line that represents the open hole OD. We can toggle it off and click refresh to see what the schematic looks without it. Now let's go ahead and toggle it back on and click refresh to restore it. We'll leave it on for now. The cement shoe track is only added to the smallest casing string. By default, it is 40 feet in length, but we can increase it to 120 feet and refresh it to make it more distinct. Or by unchecking the box and clicking refresh, we can remove it altogether. Let's check the box to turn it back on and restore it again. The last option is the open hole trace. We'll shorten the casing string to 23,000 feet, indicating that the casing came short of making its TD, leaving a little more than 3,000 feet of open hole. The diameter of this hole will need to be adjusted to be accurate and can reflect smaller diameters or larger diameters for underreaming applications. First, we will set the diameter to 8.5 inches to demonstrate an underreamed open hole and click refresh. The larger bore hole is now visible below the production casing, indicating an underreamed hole. Let's set it to 6 1/8 inches now and refresh the well bore. Now let's review some of the features of this schematic that we created. First, lead and tail cement interface. You can see the lighter cement as lead and the darker cement as the tail. Second, the cemented liner including a liner hanger. Third, a partially cemented tapered string. And finally, an open hole section below the casing. This completes the casing section. Be sure to check out more videos to learn about all the features of Whalebore Genie.